Hello, this playlist is the third of a series of playlists related to the funnel case, in which what we want to do is a capacity analysis of a plant by means of using a simulation model built in Simio. I recommend you visit the other playlist where we had this system, where we had bars entering the system and valves shipped to the customer after a series of transformations. And in the first playlist, I described in detail how the system worked and what the problem was. And in the second playlist, I showed how using a simulation model built in Simio, we could explore the different changes we can introduce in our system and see and evaluate the impact in terms of hourly production and eventually to decide whether an investment is worth it or not. So what we could first do is a static analysis. This is a table where we have all our processes from the saw all the way to the cleaner, and we have the information relevant for analyzing at least as a first approach to the problem. We have, for example, the saw, which works with a lot size of 3 because we have a bar entering the saw which is cut into 3 pieces, and this takes 6 minutes, which gives us a maximum production rate of 30 valves per hour if we were only looking at this process. But we have either breakdowns or setups. This happens for several processes in our system. And in this case, what we have is that we have a repair time during which this process is not available, the saw is not working, which follows a triangular distribution. And we can assume that pretty much we have 25 minutes unavailable or an availability of the saw every 100 minutes. So this gives us this 20% of the time that is not available for us to cut the bars. So if we're reducing in that percentage the maximum production rate, this 30 is converted into 24 valves per hour. We could do something similar for the rest of the processes. I leave you the table here for you to check. And we could see that the inspector is the one which should be or seems to be our bottleneck because it allows us to produce at a rate of 2.86 valves per hour. This is the static analysis, but we could make decisions based on this and decide to improve the inspector. But this is a very poor analysis because it does not take into account how unused capacity of a process propagates downstream, or it doesn't take into account whether we can make the best of the uses of what happens upstream the bottleneck. So we need to do a more accurate and valid analysis, and that is why we use simulation instead of that very simple analysis I just showed. But before we go into Simio and do that analysis, a warning is needed. We are doing something which is a simplification of what we should really do. Randomness requires very careful treatment. What we're going to do is running the model just once, but these might lead to wrong conclusions. We need to run the model several times. We need to do several replications that allows us to obtain a representative characterization of the performance of our system. We're doing this only once because the difference we're going to see in this first approach is very obvious. But if we were doing this in the real world, we should do several replications to make sure that we have confidence intervals, we have a very good estimate of how our system will work. We're doing only one replication, but keep in mind that this is not the systematic and the right way to do these things. Okay? So let's go and explore different alternatives and how our system performs using our Simio model.